Howdy everyone, and welcome to our talk on dynamic HAProxy at scale, Roblox's infrastructure evolution. A few quick introductions before we get started. My name is Chris Jones, and I'm a software engineer on the traffic team at Roblox. I've been with Roblox for 3.5 years, but I actually started as an intern. I had a great internship experience with Roblox, and I was happy to return as a full-timer after graduation.
My name is Ben Meidel. I'm a senior site reliability engineer on the traffic team at Roblox. I've been at Roblox for about 5 years. Currently, I work with load balancers, but I've worn many different hats during my technical career: network engineer, wireless network engineer, security engineer, software engineer, and even tech support engineer.
Quick table of contents for what we're going to talk about today. We'll start by explaining what is Roblox, and then we'll get into the history of load balancing at Roblox and how HAProxy factors into that history. We'll then talk about our in-house Roblox load balancer solution powered by HAProxy, and then we'll discuss some tooling surrounding creating extra visibility with logs and metrics. Then we're going to talk about some HAProxy Enterprise enhancements, most notably dynamic updates and the WAF module. Finally, we'll talk about our automated build pipeline, and then we'll end with a Q&A. So let's talk about what is Roblox and the scale of our systems. So for those that haven't heard of us, what exactly is Roblox? To put it simply, Roblox is an immersive gaming and creation platform. We provide and maintain the Roblox Studio software, a free experience creation tool designed for both accessibility and power, and the Roblox platform itself, where experiences like games and other social spaces are hosted. The Roblox platform also offers built-in social features, like chatting with your friends over voice or text, and an extensive virtual economy, featuring things like in-game purchases to enhance your experience, and avatar items to help our users express themselves to the fullest. The content hosted on Roblox is almost entirely user-created, making it a unique platform for both devs and users alike. One of our most important tenets is that of safety and civility for all of our users. We want our platform to be one where everyone is empowered to create, learn, share, and thrive, no matter who you are. TLDR, Roblox is a UGC platform where anyone can create what they want, spend time with friends, and be safe doing so. To give some idea at the scale at which Roblox operates, here's some interesting numbers, all these as of Q1 2025. We have 97.8 million average daily active users of our platform, with 2.8 million developers creating experiences. We host 6.4 million active experiences and have reached 21.7 billion hours of engagement. As you can imagine, this many users require high-performance, scalable solutions, which is a major factor in our usage of HAProxy as our load balancing solution of choice. We currently manage hundreds of HAProxy instances across the globe in both edge and core data centers, and at our edge layer, we handle millions of RPS all the time. But we weren't always powered by HAProxy.
Now, I'm going to talk about the history of load balancing at Roblox and how we migrated to HAProxy. In the beginning, we had F5 hardware load balancers. They were fast and performant and met our needs up until COVID happened. We experienced tremendous user growth during COVID. COVID was a very stressful time for the world, and we were glad to be able to provide a safe online environment for people to meet up, have some fun, and unwind. However, such tremendous growth came with challenges and required new scalable solutions. Using hardware load balancers was no longer cost-effective, and even if they were, we couldn't source enough to meet our needs during a time of such supply constraints. So we explored open source software-based load balancers that we could run on general-purpose Linux servers. We considered many options, but ultimately decided on HAProxy due to it being a tried-and-true solution with the features we needed. OCSP stapling was a standout feature at the time, and most of all, its fantastic performance. At first, we ran HAProxy on bare metal servers and managed the configuration and deployment with Ansible. This worked well for a first iteration, but it had some drawbacks that we needed to address. There were several big cons of this legacy design. First, deployments were slow. Ansible is a good tool, but it isn't the fastest, especially when you're dealing with hundreds and hundreds of servers and expensive database calls to gather all of the variables needed to render a complex HAProxy configuration. This meant we were not as flexible as we needed to be. Pushing out updates quickly to address urgent changes was difficult, changes such as changing the load balancing algorithm for a specific service, for example, round robin to least con, that sort of thing. Ultimately, there was a lot of engineering toil at all levels with this legacy design, and nobody likes toil. We needed a new and improved solution.
That solution is our very own in-house Roblox load balancer, or RLB, powered by HAProxy. At Roblox, we believe that a simple name is the best name, especially on an outage call. Roblox Load Balancer, or RLB, is a scalable proxy solution built with HAProxy. There are a few key advantages over our legacy load balancing solution, the largest of which being its self-service nature. RLB, which is currently built on the HAProxy Enterprise Docker container, leverages console template RB to scrape our internal console service registry, allowing service owners to self-register with RLB by simply adding the right console tags to their service, and then they receive traffic. We also allow configuration of features such as load balancing algorithm with console tags, so that service owners can customize their load balancing to fit their needs. All of this can be done without any communication or involvement with the traffic team, greatly reducing engineering toil for all involved. Additionally, RLB is scheduled on Nomad as opposed to running on bare metal, like our legacy solutions. This means deployments are easy, fast, and reliable. Not having to worry about individual servers makes deployment much simpler. Orchestration also means the jobs are self-recovering. In the event we have instances go down for whatever reason, they're automatically rescheduled on other available servers, preventing a loss of capacity. However, as y'all surely know, it's not enough to simply provide a really cool load balancing solution. Migration from one load balancing cluster to another can be a difficult task, especially when your objective is to perform migrations live with zero downtime. So we now have the new task of migrating services from our legacy solutions to RLB. But at the same time, service owners were also performing their own migrations from legacy Windows Server architecture to new, modern, containerized deployments. There are obviously many questions from service owners directed at us during these processes. So we need to be able to adequately answer these questions and back up our answers with solid data. So how can we provide this data? The answer is with logs and metrics. The next section, we'll explore some tooling we've developed that has allowed us to gain increased visibility by utilizing logs and metrics in creative ways. To start, here's a quick anecdote about our history with logging. When we first tried to enable logging from our load balancers to our central log infrastructure some years ago, it actually crippled our logging stack due to the sheer amount of logs we were sending, and our logging team kindly requested that we not do that again. So we learned we can't directly use the logs themselves to help us answer questions about load balancing. How can we still glean information from those logs? We created a tool to answer this question. Following our aforementioned simple name policy, log to stats is exactly what it sounds like. It ingests HAProxy log lines over a Unix or UDP socket, parses them, and generates Prometheus formatted metrics based on those logs. It's written in Go for a good balance between ease of development and performance, and lives as a sidecar container running on the same host as HAProxy. The metrics generated from HAProxy's highly customizable logs allow us to gain visibility into information not natively provided by HAProxy's built-in stats. Most notably, this allows us to group metrics by labels such as host header and status counter, which can be particularly useful when you have a lot of traffic flowing through the same front-end, back-end proxy flow that you want to differentiate. In addition, a key field the logs provide, not already present in the HAProxy stats, is the termination code of a transaction. For those that may not be aware, HAProxy provides a termination code for each request-response transaction that describes the final state of that transaction. For example, it can help tell us if the backend server connection failed or timed out during the response, or maybe the client disconnected early, etc. But the key feature of the termination code is its ability to tell you when nothing went wrong and the proxy worked exactly as expected. This is especially key during potential incidents where the root cause is not yet fully understood. In these cases, it can be easy for people outside of our team to point some fingers at the load balancers, and it then becomes the job of the load balancing team to absolve them of guilt, so to speak. The termination code has come in handy for this exact purpose many times, and has allowed us to speed up troubleshooting immensely by quickly removing the load balancer as a potential source of issues. We have since upgraded our logging infrastructure to handle the increased load of HAProxy logs, but log2stats metrics still provide immense value as a quick way to access data and correlations based on our logs. Suffice to say, it has become a valuable tool in our HAProxy orchestration toolkit. Another visibility issue we face is with HAProxy stick tables and other information exposed by the HAProxy admin socket. Quick rundown on stick tables. They are flexible, high-performance key-value stores built into HAProxy. They provide an easy way to accomplish tasks such as rate limiting, but it can be difficult to view the contents of these tables as they change. These, along with other information not found in other places, can be viewed manually by sending commands to the HAProxy admin socket, but this isn't very scalable or flexible. We needed a way to increase our visibility into these tables.
So we came up with Socket Exporter. Socket Exporter is a service we run as a sidecar alongside our HAProxy load balancers that periodically scrapes the socket for metrics not natively available in HAProxy. We would prefer all key metrics to be available natively, hopefully soon. Stick table data is one of these metrics. We gather the data from these tables and then populate the data in a custom Prometheus metrics endpoint our telemetry services can scrape. We also gather dynamic update success metrics and OCSP update metrics as well. Right now, we gather these metrics from the raw HAProxy socket, but we will soon start using Data Plane API. More metrics means less surprises. The improved visibility we've gained from log2stats and socket exporter metrics have helped us with everything from service migrations to troubleshooting service and load balancer issues. We've found great value in them, and so have many teams at Roblox.
While we have been able to greatly improve our efficiency at orchestrating HAProxy with the tools and features we've discussed so far, there are still plenty of ways to improve our orchestration abilities, especially once we partnered with HAProxy Enterprise. We're about to get into our usage of HAProxy Enterprise specific features to further improve our load balancing setup. But before we do, here's a quick overview of our Enterprise suite and some of the features we've been leveraging. The Global Profiling Engine, or GPE, allows us to collect and aggregate the aforementioned stick table data across HAProxy instances and clusters, providing a more unified setup. Dynamic updates allow for the updating of map files on the fly automatically by hosting the relevant files on a web endpoint. And HAProxy Enterprise WAF provides a flexible and powerful security framework integrated right into our existing load balancers. Finally, I want to give a big shout out. Access to enterprise support has been very helpful. We often find ourselves deep in a documentation rabbit hole trying to find specific information. And in those times, it is a huge relief to just be able to ask someone who intimately knows the software for input. Now let's get into the details about the particular ways we've implemented a couple HAProxy Enterprise features. The first of these features we'll discuss is the Dynamic Update module. So, what are we trying to do with dynamic updates? What problem are we solving? Well, map file distribution is hard. At runtime, HAProxy reads from map files and other consumable local information in order to make routing decisions. Map files, which can contain things like a mapping of host header to backend, are incredibly powerful and flexible, but they can be difficult to distribute at scale. Even with a nice orchestrated load balancing solution, manual map updates can take time and toil, with far too many engineering hours spent on what should be relatively small changes. We needed a way to distribute this consumable information quickly and easily while keeping our systems online and reliable. How can we accomplish this?
The solution? Dynamic updates. Dynamic updates are an enterprise feature that allow you to update the contents of some things like map files without needing to reload HAProxy. Very handy. The way we implement this is to store our map files in a GitHub repository. Then, when we need to make a change, we open a pull request to update the map file. Once it is approved, we have GitHub actions configured to automatically sync the contents of the map files to console KV in our POP HashiCorp stacks around the world. Console KV, for those of you who may not be aware, is a key value store for objects that's very handy to use to dynamically configure applications. It also ties in very nicely with console template and Nomad template. In these POPs, we have web servers running that watch console KV for changes and automatically download them and serve them up on HTTP endpoints formatted for HAProxy to understand. The HAProxies then use the dynamic update module to fetch the contents of these map files and update them without needing a reload. The whole process usually takes about 20 minutes to update all of our POPs. The GitHub actions that sync the map file updates to console KV do our POPs in small batches and automatically watch for any negative changes in key metrics along the way. If the metrics start to look suspicious for any reason, the update is canceled, whether or not our change is the root cause. Better safe than sorry. Many of the key metrics we watch are actually pulled from our custom log to stats metrics that Chris spoke about. We also have a break glass GitHub action that we can manually run if we need to immediately push out a critical update without regard for metrics, such as during an outage. This has proven to be a significant improvement in how we manage our HAProxies, and here are some of the highlights. All of these actions here are as simple to configure as approving a GitHub pull request. Traffic splitting allows service owners to easily split traffic between data centers for testing and verification, or to shift load around. The same is for service migrations onto RLB or between different RLB clusters, depending on the service's needs. We've successfully migrated hundreds of services without any intervention from our team needed. We also gate certain HAProxy features using ACLs that check for values in map files, so enabling and disabling them doesn't require a full deploy or even a reload. Routing traffic and rewriting paths on demand has never been easier. Even subnet updates for specific traffic routing based on source IP. These success stories are just a few of the ways dynamic updates have helped us and proven to be a valuable tool.
Now let's talk about our implementation of the HAProxy Enterprise Web Application Firewall. Another ongoing issue we face is regarding our various security solutions for dealing with malicious traffic. While Roblox has tight security at all levels, that security can often come in the form of various implementations throughout the network stack. These solutions can be inconsistent with their implementation, difficult to manage, and can create toil with our security team. We needed a single, centralized security solution that was powerful enough to provide adequate security, flexible enough to adapt to our network and the ever-changing landscape of cybersecurity, and simple and easy to use, with full control in the hands of our InfoSec team. Bonus points if that solution can be integrated into our existing tooling and provides extra visibility to help our InfoSec team perform at their best.
Web Application Firewall to the rescue. Web Application Firewall, or WAF, is a Layer 7 firewall that you can run in HAProxy that helps identify and filter malicious requests, stopping them at the load balancer level and protecting services. It filters, monitors, and blocks malicious traffic. Thanks to our implementation of dynamic updates, our security team can onboard services to Web Application Firewall at their own pace. We can even enable enforcement for only a certain % of traffic to a service to slowly and safely ramp it up. The required configs for this are in map files, including the host headers or paths that need enforcement and the % of enforcement. The host header and path are the key in the map file, and the value is a number for the % of WAF enforcement. I'll share an example in a few slides. Dynamic updates make WAF deployments very simple, whether it's ramping up traffic, adding whitelists to rules files, and more. Finally, WAF on the edge load balancers provides a convenient centralized solution for Layer 7 security. Rolling out updates to address vulnerabilities is faster than doing it further down the stack, like on the services themselves. And it has great logs and metrics. A single pane of glass, so to speak, much easier to monitor. So here is a quick summary of how we onboard a new service to WAF. Our security team opens a pull request against the map file in GitHub. Then we approve and merge the pull request. Once merged, GitHub Actions push the map file updates to the remote console clusters. This is done on a staggered cadence, a few pops at a time, and key metrics are monitored along the way to minimize surprises. The remote POP web servers pick up the changes and serve them up for the HAProxys to fetch via dynamic updates. Seamless. And we have logs and metrics for service owners to monitor the whole time. Okay, here we can see a config snippet of our implementation of WAF for some more details. The top part is from the front-end config, and the bottom is the relevant map file. In the map file, we specify the paths of the services to onboard along with the % of traffic we want WAF enabled on. This allows for a gradual ramp-up of WAF enforcement. In the front-end config, for each request, we first set a variable that is a random number up to 100. Then we set a variable that looks up the value specified for the path in the map file with a default of 0 if the current HTTP request's path isn't in there. That means no WAF enforcement at this time, or the number isn't specified. For foo.roblox.com here, that number is 50, meaning we want WAF enforcement on 50% of the requests to this service. In this hypothetical situation, we're in the process of ramping up WAF on this service. Then we do a check for the current base in the map file to see if it's in there and should have WAF enforcement. Checking the ACL first for every request saves resources if the request isn't meant to have WAF enforcement at this time. No further action needed. However, I do want to mention that we've been extremely impressed with the performance of HAProxy's Web Application Firewall. Anyway, then we set an ACL that subtracts the random variable from the value specified in the map file and checks if the value is greater than 1. The math works out so that the number specified in the map file is the % chance of WAF enforcement. If the ACL is true, the filter is applied, and if the WAF block ACL is true because the request is considered malicious, the request is blocked. We also track these violations in a stick table called WAF table enforce, and we can see them in our awesome metrics courtesy of the socket exporter service. In summary, Web Application Firewall has proven to be a great tool in our security tool belt, and one of the best things I can say about it is this. Picture what happens when a new security vulnerability is discovered. When this happens at Roblox, people are concerned, understandably. Which services are affected? How has the vulnerability already been exploited? How quickly can we protect our services and players from it? Well, in a situation like that, there is nothing more reassuring than knowing that we're already protected thanks to WAF. We share the documentation confirming the protection and also share the logs that show if bad actors have already tried to exploit the vulnerability and failed. This has already happened several times at Roblox since we've implemented WAF, and it's made for fewer urgent same-day service updates to address newfound vulnerabilities, and instead some very reassured and very happy service owners.
Now, even with the improved tooling offered by enterprise features, there are still enhancements to be made outside of HAProxy itself to improve our orchestration experience, most notably the implementation of a build pipeline. So what problem does a build pipeline solve? Well, when you're deploying manually, jobs have to be monitored, metrics need to be watched during deployment, and there's even a lot of manual testing that needs to be done before deployment to prod can commence. Even with improved deployments, due to previously mentioned Ansible to Nomad migration, there still needs to be an engineer managing deployments across sites, which is especially difficult at a global scale. Difficulty with deployment can lead to config and version drift, and it encourages engineers to pack multiple changes into deployments to minimize how often they occur. Not a good strategy for reliability. How can we even further reduce the time taken for deployment tasks and make deployments as easy as possible?
So we came up with an HAProxy build pipeline. A build pipeline is a core part of the continuous integration, continuous delivery DevOps principle that allows us to streamline how we push out updates to our load balancers. A good build pipeline improves trust in the system and minimizes surprises during rollouts, which is especially important when you're rolling out major updates like new HAProxy versions or new modules like WAF. For our build pipeline, we separate our HAProxy load balancers into canary and production instances. Our canary instances are about 5% of our fleet, and we do a daily build, business days, where we pull and deploy the latest HAProxy Enterprise image for the major version we're currently running. This also keeps us up to date on things like the WAF rules binary. Using the HAProxy Enterprise Docker container has been a big help here, a convenient base image that is easy to manage and deploy. Our daily 5% rollout is slow, a few pops at a time, and key metrics are automatically monitored. If there are any issues, the daily build is paused and we are notified. Once the daily build is complete, we can promote it to Canary and roll it out to all of the load balancers when we're ready. This is all done via GitHub Actions. This allows us to dog food major changes and catch surprises as quickly as possible. Rolling out major changes to only 5% of our fleet at a time also simplifies rollbacks if necessary. In summary, our build pipeline helps us to have more confidence in our load balancers, has spared us from toil, and greatly improved our day-to-day operations. It is a big step forward in our infrastructure evolution.
So, finally, before we finish with the Q&A, we wanted to invite y'all, if you found our discussion today interesting, to come check out our open opportunities. What we've talked about today are just a few of the interesting projects at Roblox, but there are always new innovations happening throughout the company on our various teams. So if you find an open position that you think you might be a fit for, we invite you to apply and come join us. Now let's open up the floor. Thank you.
Gentlemen, great stuff.
Thank you.
So we do have a few minutes for questions. So again, raise your hand nice and high if you'd like to ask a question. I think we'll have a few. We do have one that came in on the stream, so we'll ask that. We're getting the mic over there. How does Roblox deal with the volume of logs and metrics?
Very carefully. We have a robust logging pipeline that is maintained by a dedicated team at Roblox that is constantly improving and updating. Some of the specifics of that would be beyond the scope of the presentation, but it is a constant, it is always something. You know, everybody wants more logs, more metrics, more visibility, and to be as nice to that team as possible and be as respectful of resources as possible. That's why we've been so creative with our metrics.
Hi. Knowing what you know now, what can you advise someone who's migrating F5 to HAProxy Enterprise?
Ooh.
And what's one major consideration that you feel that should have been there from the very beginning if you can do a do-over?
That is a good question. For migrating from F5 to HAProxy, do it slow, have lots of metrics, have as many logs as possible, key metrics across the board. And I'm going to give a shout out to HAProxy Enterprise here. I would say that we originally did this at first without HAProxy Enterprise, and if it's at all possible, I'd recommend partnering with HAProxy Enterprise for getting sanity checks on configurations. And also, you know, if you can, focus on doing it as dynamically as possible from the get-go, if you get to do it like in a proper greenfield environment. We had, there's the old classic analogy of, you know, you're trying to change the wheels on the bus while the bus is going 70 miles an hour. Our growth was so exponential during COVID that we had to make some sacrifices in terms of some things that we wanted to tackle right away. And we kind of had to push it to the back burner a little bit just so we could keep things going as stable with the experience that our users require.
There's someone back there, if you can get the mic to them. There is one on the stream that I can ask. What sort of data does Roblox convert from stick tables to metrics?
You want to take that one?
Sure. Well, we mentioned stick tables are a really good, easy way to rate limit. As we decide on what should an adequate rate limit be for a given service, having something like the host header for that service in combination with the request rate is extremely handy to export and graph historically. You can tell, oh, here's the absolute peak of this service's rate, and here's the minimum, what's steady state and stuff like that. So yeah, just something like the request rate of a given host header is extremely handy to view via metrics.
So I was going to ask the most important question, which is Dundee's World or Grow Garden for you. But really, the question is, what's next on your roadmap, personally? What are you trying to do next?
More dynamic. We would like to focus as much as possible on minimizing reloads on our HAProxys. That's definitely something on our roadmap. I'm excited to hear some of the things in the works here at HAProxy about ways that HAProxy can be built more dynamic and require even less reloads than it currently does. and a few other things as well. But I'd say that's the biggest one that I'd like to shout out.
And I want to tackle real quick. You mentioned Grow a Garden. If for those that are not aware, Grow a Garden is a relatively recent experience. An experience that has recently become very popular on Roblox, and has recently been breaking records for concurrent players in a single experience, which has been very interesting for us. And it has proven to me, especially, I mentioned I've only been here 3.5 years, but it has proven that running a UGC platform like this, you can't always predict what's going to happen on a week-by-week basis. You can try based off historical data, but someone may show up, make the next Grow a Garden, and suddenly you have a lot more load to deal with that you weren't expecting, and you have to deal with that. So always plan for more than you expect.
So there was a question in the stream, you partially answered it already, but related to becoming more dynamic, and what you mentioned, of course, how do you so the question is, as a user-generated content platform, how do you handle spikes in traffic for popular games like Grow Gardens and events?
I can go for it, Chris.
Sure. Well, I mean, obviously nothing beats sheer capacity, which is something we're focusing on, but also just doing everything we can to optimize our usage. Blocking traffic that we don't need to transfer earlier to save CPU usage further down the stack, as one example. But yeah, just making sure that we are focusing not just on capacity, because that's often a pitfall, I feel, that you throw enough load balancers at the equation and everything will work out. That's not always the case. You also need to focus on how you use your load balancers and making sure you are using them optimally. So.
I also want to give a shout out to Chris here, especially for a lot of the hard work that has been done on logs and metrics. Because as you scale, I'm sure folks here are familiar with discovering bottlenecks and pain points that nobody could have possibly thought about. It's like, wait a second, the NIC, we're saturating the NIC on a proxy server somewhere or a caching server. Wow, that's a new one. So it's having as many metrics and logs as possible to minimize surprises is always a huge plus there.
Last question. Any performance impact from enabling WAF on your traffic?
Honestly, I couldn't tell. It was so impressive. I set up everything with making it as, we can scale it. Because of course, one of the big points about scaling up WAF is you want to make sure that everyone's comfortable and confident with enabling something as important and potentially impactful as WAF. But we have been extremely impressed with HAProxy Web Application Firewall. I turned it on a full blast in learning mode in one of my load balancers and one of my edge pops when I was first messing with it. And I'm looking at my metrics and it's like tap, 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 is that updating correctly? Is this on? It's working. Everything looks pretty good. So yeah, no, it's been awesome. I literally so far have not really been able to tell in terms of CPU, which is always one of the biggest things we monitor because of TLS. It's excellent work.
Very cool. Well, Chris, Ben, thank you so much. Give it up, guys.